Happy Friday, everybody. Let's go ahead and work on quadratics and wrap this up today. So up to this point, you've worked on identifying what quadratics are and graphing quadratics, and you see I have one graphed right here. Today, we're going to work on solutions of quadratics. Now, for what it's worth, the word solution is perfectly acceptable for everything we're doing, but there's two other things you could use for the word solution as well. You might hear solutions referred to as zeros. All right, if you hear zeros of a function, that's another word for solution. So zeros would be something to queue up. And another one would be called roots. In Algebra 1, we tend to use zeros more. If we were in class with one another, I'd be saying that all day long. Next year in Algebra 2, you're going to hear the word roots more often, like find the roots of, which is just another way to say find the solution of. So zeros, roots, solutions, all the same thing. So don't stress that. That's simply what it means. Now, when we look for roots or solutions or zeros, all the same thing, of a quadratic, what we're actually looking for is the point where the graph touches the x-axis. So if I have a graph that looks like this one, I have my equation touching my x-axis in two spots, right there and right there. Now, I'm not immediately sure what those things are, nor do I really care for this purpose of the video. All I'm going to say that this has two solutions. And we could identify what those two solutions are. We're not really worried about it right at this moment. Let's move on to the next one, right? This is also possible. You could have a graph where the curve or the parabola only touches at one spot. If it only touches at one spot, then we only have one solution. We care about what that solution is, but we only have one of them. And you could probably imagine that what would happen if we had this thing hovering, either opening this way up above my x-axis or like an umbrella down below the x-axis. If there's no touches, then there's no solution. Now, the only thing that I would probably change, and this will be kind of a piece of terminology only, it won't really matter until you get into Algebra 2. But the truth is what we'd say, you might say no real solutions. Because there are solutions, as weird as that seems, but they are imaginary, and that is for a whole different day. In fact, for us, that's going to be for a whole different year. You're going to learn that in Algebra 2. We'd be learning it probably at the tail end of this year if we were in class together. So we have three options. We have sometimes when you have two solutions, sometimes when you have one solution, and sometimes when you have no real solutions at all. But I don't really want to have to graph each one of these. So even though today's directions in the textbook are going to say graph, in the typed directions, it will say clearly do not graph, because while graphing is great, and we're going to spend a lot of time graphing as you get better at math and better at algebra, today we're going to do it without. So check this out. To solve or to find zeros or to find roots, all you're going to do is take the equation that they give you. In this one, y equals n squared minus 81. And we're going to swap out the y with a 0. We're simply going to trade them out. The idea being, if what we're looking for is the spot where our line touches the x-axis, well, one thing I know about anything that touches the x-axis, when it's touching the x-axis, the y is going to equal 0. The x could be a variety of things, but the y is going to be 0. If the y is going to be 0, then let's go ahead and just swap out 0 for y, and then watch this. You just solve. So I have n squared minus 81. I'm going to add 81 to both sides. To get rid of the squared, I'm going to square root both sides, right? Whatever I do to one side, I can do to the other. And the square root of 81, I'm thinking about a number that multiplies by itself to give 81. And I can think of 9, and I could think of negative 9. So I could either write it as negative 9 and 9 equal n, or a little bit fancier will be plus or minus 9. That'll still show two solutions, right? So there's two solutions, and we actually identify what those two solutions are. Good. So let's go. Oh, by the way, if we graph this thing, we wouldn't be surprised to see that it touches the x-axis twice. Once on the left side of 0, 9 spaces over, and once on the right side of 0, 9 spaces over. Now, let's look at two more examples, and then we'll finish with one more, and we're all done. Now, example number 2 looks a lot more confusing, but look, it doesn't need to be. Let's go ahead and just solve for n. So I'm going to get rid of the minus the 29 first with minus 29 is negative 40, what are we at? 47. Is that right? I think so. And then we're going to divide both sides by negative 3, and I get n squared equals, what is this? This is different than I worked out in my example. So negative 15 and, yikes, 2/3. This is really, oh, not negative. 15 and 2/3. Now, this is actually an example that I did not plan on it working out like this. My numbers are a little bit out of whack, but oh well, because watch. I still square root both sides to get my two answers. The only difference is I need to square root something that is, well, kind of not a perfect square. So I think I have my calculator tool here, 15 and 2/3. I'm going to grab my calculator. I need the square root of 15 and 2/3. So square root of 15 and 2/3. I'm going to cheat a little bit and do one of these things. I think that's enough sixes. And there's my answer, 3.95. I'm going to round it to 3.96. So let's go back here, and I'm going to say n is approximately, because I did round, 3.96. And because I have two different answers, the positive version and the negative version, I'm going to say it's plus or minus 3.96. And I think that would do the job. Let's look at example number 3. Example number 3, n squared plus 25 is 0. Same routine. I'm going to subtract 25 from both sides. I'm going to go ahead and take the square root from both sides. And I need, okay, so just like last time, I need the square root of negative 25. So square root of negative 25. Negative 25. Syntax error. Oh, maybe I didn't have a parentheses in there. All right. Math error. So let's go back and look at this. So that makes me think I need to come up with a number that multiplies by itself to give negative 25. Oh, I can't think of a number times itself that would produce a negative, right? Positive times positive is positive. Negative times negative is positive. I can't get a number times itself to be negative, which is why I'm going to go ahead and write here, no, and here's the key, no real solutions, because there are imaginary solutions to deal with. But for now, we're going to go ahead and say that there are no real solutions, and we're done, right? So if you see anything that looks like this, when you're taking the square root of a negative, no real solutions. Now, final piece, just so we have this as an example. Oh, by the way, if we graphed example number 3, you would expect this graph to be either above or below, but not crossing the x-axis. It's not going to touch the x-axis. That's why we have no real solutions. And for the last one, example number 4, we're going to solve for n one more time. So think about what you would do. Minus 3 to both sides. N squared is 0. Square root both sides. All right, so I need a number times itself equals 0. 0 doesn't hold a positive or a negative value. It's not positive or negative. It's just 0. So I'm going to say n is 0, and there's no reason to put plus or minus, which means this is an example of a one-solution equation, right? If I graph this thing, it would come down, it would touch at exactly one spot, and then it would probably go right back up again. So a couple different things you can think about. 1, you're solving for n. 2, you're solving with square roots. And 3, you could have three different types of answers. You could have 2 solutions where you list both. You could have 1 solution where you just list the one, or you could have no solutions where you actually say no real solutions. All right, good luck.